All right, hello everybody. Thanks for joining this talk. My name is Sasha Parfenov. I'm an Apache Apex committer and a software engineer at DataTorrent. And today I'll be talking to you about visualizing big data in real time. Most of the talk I'd like to spend on a live demo because I like to live dangerously. But before we get there, I'd like to tell you a little bit about Apache Apex. And maybe you can help me out by show of hands. If you could raise your hand if you've already worked with Apache Apex before. All right. So I have a little bit of explaining to do before we get to visualizing the data about what is Apache Apex and what is DataTorrent RTS. Then we'll jump into the demo. And then I will probably skip most of the technical content, but you can talk to me after the presentation and get more details if you're interested. So let's jump in. What is Apache Apex? I think it's one of the best ways to develop your big data applications that's available today in the Apache community. It was originally built by DataTorrent as a proprietary streaming engine, and it was eventually open sourced in 2015 and became a top-level Apache project in 2016, which was very exciting. I was with DataTorrent throughout that time that we went top level, so it was very fun. Some of the customers that we had for Apache Apex were already there before we became top-level projects. So some of the use cases that those customers were trying to solve, for example, in IoT space, one of the customers is GE, and they have a lot of devices and sensors that are sending a lot of data in real time. And we've been able to demonstrate that the platform can scale to process over 1 billion events per second in real time, keep up. And this is a linear scalability on a relatively small cluster size. So it'll continue scaling to many billions of events if you keep going and keep adding nodes. Some of our other customers were focused on financial sector, such as Capital One, and they were interested in processing credit card transactions and determining whether those transactions are fraudulent or not in real time. So to achieve that, this is when you swipe your card or insert the card with the chip, and the end-to-end transaction needed to be sub-second. But the actual time you have for the system to process it is much lower than that because there's a number of network hops before you get to the data center. So they need to be able to process it. Their goal was to do it in about 40 to 50 milliseconds. And we were able to demonstrate end-to-end processing inside the Apache Apex platform in under 2 milliseconds. So it's a very fast engine compared with some of the others that work slightly differently that are out there. And then if some of the customers that we have that do not have such high need for scalability or such low latencies, they use it for even traditional ETL loading of data into their data sources. Because the system is very fault tolerant and it'll automatically recover if you lose a node or even part of your cluster and continue processing without having to restart and go back to the very beginning of the computation. It will just restart from the time that the distributed checkpoint was taken and continue processing the events. So the recovery is very, very fast, and you're back up and running in real time really quickly. So those are some of the benefits in terms of what the platform gives you. But one of the nice things about how it's deployed is that it's Yarn native, which means the installation is very, very fast. You can be up and running with native Apache Apex in, there's no installation at all. You just launch it, and as long as you have a Hadoop cluster set up, as long as you have Yarn and HDFS available, then it'll just start running. And if you wanted to use it with DataTorrent RTS, which we'll look at in just a moment in the demo, that setup, it takes seconds. So it's very fast and easy to install. And of course, most importantly, for those of you who are developing or are considering developing with Apache Apex, I think it's very, very easy to develop the applications. in Apex. It allows you to develop your code in Java or high-level API or in Visual Assembly, which I'll show you briefly. And for those of you who are getting started, there's already a large library of operators and example applications that is available. And you can find everything to connect to any kind of file system, messaging queue, also perform computations, parsing, etc. And being good Apache community citizens, we're also integrated with a lot of other Apache projects that you may be familiar with, such as CalSite, Samoa, Beam, NiFi, Geode, etc. So typical use case, what does it look like when Apex is running? Like what part of your ecosystem does it occupy? So it's what you see in the central blue box there. First, you have events coming from your data sources, such as Kafka, maybe Solus. You can have files on S3 or HDFS, pretty much anywhere. You can either you're reading files or you're connecting to messaging services and getting messages. They flow into the system. They're processed through an Apex application, which runs natively, as I said earlier, on your Hadoop, Yarn, and HDFS clusters. And we support all types of distributions, including Hortonworks, MapR, Cloudera, EMR, etc. And then you can, when the computation is finished, you can write your data out to various data stores, such as maybe Cassandra or a traditional database, or just files back on HDFS, maybe into Hive. As well as you can produce in real time these actions and insights on your data even before you write them to the data sources. So that's something that we occasionally mention, this concept of shifting left. Other folks in the industry have other terms for what they call it, but it's instead of you first receiving your data, then doing some processing, transformations, and then writing it to some kind of store, and only later you're querying that store, and you're having to build indexes on it, and then you're getting your actions, insights, and analytics, which is a lot of what you've seen probably at other talks earlier in the summit. Our goal is to try to get you to as much as close to real time as possible by moving the actions and insights to the left of the data store. So basically we're accessing queryable state on Apache Apex operators, and we're able to produce visualizations, get metrics, and take actions before it ever lands into some kind of store. So your things are happening in millisecond latencies. That's how our customers are able to achieve such low latencies and take advantage of the platform. So what does an Apache Apex application look like? On the top left, you'll see what we call a DAG, which represents an Apache Apex application, stands for Directed Acyclic Graph. It's a series of nodes connected with directed lines. And you'll see things like input, parser, counter. Those are the types of what we call operators that are performing certain kind of function. And then when the function is done, the output goes to the next operator over a stream. So that's what an Apex topology looks like. It's a series of operators connected by streams, and they run in a distributed manner on your Hadoop cluster. And example below might be a little bit small. I'll see if I can zoom in. But this is a way that you can write. Let me try again. This is how you can write your application. This is one of the ways, and this is the way of doing it in Java. You declare an application, and inside your populate DAG method, you add your operators, and as you can see, the individual names like input, parser, counter all appear in a logical representation above. That's what you're naming your operators, and then you're instantiating classes with your own logic of what they will be doing, and then you simply connect the operators by streams, which are like lines, words, and counts here, shown above, and that's pretty much it. That's most of how the applications are developed. So if we look at Apache Apex and where data torrent RTS fits, So as we mentioned, Apache Apex runs natively on the Hadoop cluster. So above that, you'll find the Apache Apex core runtime and the library of operators that I mentioned earlier. Then there's a data torrent RTS platform which runs on top of Apex, and it enables all kinds of things, including real-time visualizations, which is what most of the talk will be focused on. And it supports all kinds of solutions above that. So without further delay, let's jump into the demo. Some of the things I'll be showing on the screen may be a little bit small. So if you're sitting far in the back and you'd like to see more details in the visualization, there's plenty of seats available. Feel free to move up if you're not able to see it. So we're jumping into a data torrent RTS console. It's your way, kind of like the gateway of being able to manage, monitor, and visualize your running Apex apps. And this is a screen that you get to when you first installed the RTS console, which just gives you a brief overview and links to some documentation if you want to learn more. But I'll kind of go through some of the main functions that are available up above, and then we'll jump into some running apps, and then we'll get to the visualizations. So first off, when you're new to Apex and you're considering like, well, I'd like to either see maybe some demos or try building my own first application, an app hub is a good place to go. It's an online repository of applications and application templates that are available, provided free by data torrent, that you can use to start your own projects. Here, each individual application or template appears as a tile. And for example, let's say you have a use case where you wanted to maybe receive messages in Kafka and do some kind of either filtering or maybe storing them somewhere. So let's say we start with Kafka to HDFS filter app. So this will be a template for reading from Kafka, doing some filtering, and then writing the results to HDFS. When you click on one of these tiles, you get a description of what the application does. We try to include some videos to help get you started, some explanations of what the DAG for the application will look like, and then below you'll also find links to resources, including documentation and the source project on GitHub. So if you go there, you'll find all the sources that you need to get going to compile and launch your app. If you look at any one of these, you can see that some of them have already been imported, indicated by the check mark here, and some of them you can import that have not been imported yet. So when you click on the import here or inside the application description, what it does is it copies that application to your local store, which is where your data torrent RTS gateway is running, the server which is serving this UI, and it makes the application locally available for launch on your Hadoop cluster. So the next thing that we might want to do is go in and launch one of these applications. Here we have everything listed in one menu. We have applications and applications configurations that are available for launch. If some of them are running, they'll be displayed with, they will show you an active instance of one of them running. Launch is really easy. You just say launch. You can change your application name, and you can also provide some additional options or specify additional properties. And if you want to preserve these customizations, let's say you've added a few fields and you wanted to pass some custom information to your app, you can later save it as a configuration. And so then you don't have to keep providing it over and over again, and you'll be able to launch that as a particular saved configuration. So when you launch an app, it just, what it does is it submits a request to the Yarn resource manager to provision some containers, and then it allocates the containers and schedules the application, deploys the topology across your Hadoop cluster, depending on what that application, what kind of resources it needs. You can see the status of the applications here, and now we see that the new application that we just launched has come up and it's available. You can click and then get into the monitoring section, which is the next one I'd like to cover. So for example, we can also see, of course, all the list of all the running apps that we have launched. Let's pick one. So let's start with a simpler one, which is called Twitter Demo. So what this application does is it takes, the logic of it is to take input from Twitter, connects directly to the Twitter streaming API. Then it parses all the tweets that it's receiving into unique hashtags. Then it counts the hashtags, and it produces top counts of like which hashtags are the most popular. And then it connects these operators, the snapshot server and the query result are specifically there to enable visualizations, which we'll get to in just a moment. But just to point out what the running application looks like, so you can see all the details of what the application is named here, and you can see some of the stats, including how many events it's already processed, how many physical containers have been allocated on Yarn, where it's running, how much memory it's using. And you can see a number of events that have occurred with this application, including, these are changing in real time, by the way, just like the stats about how the application is running and how many tuples or events it's processing currently. And you can also get additional details in case the application is having problems about what's happening with your events, and it will tell you why certain maybe containers have been released. Like here, there was a heartbeat timeout, and it probably released this container and allocated a new one to let the application run in a place where the resources are not affected. So this gives you a little bit of an insight into what a running application looks like. So we can look at a slightly more complex application. Let's take Telecom Demo. In this case, this is simulating what a telecom operator might be doing, which is ingesting data from multiple sources, including customer service data from call centers, as well as call data records from here. It's ingesting it from a Solus messaging system. And then it's enriching the events, it's computing some key performance indicators, and it's making all of these available for visualizations somewhere later down the stream. So this is an example of a fairly complex DAG. I'll zoom out, show you a little bit more of it. Hopefully you can see it on the screen. So one of the interesting features that's available, because typically streaming applications can be hard to understand, hard to manage and figure out what they're doing, and even harder to troubleshoot if something's going wrong. And that's kind of what we focused on here with Data-Torn RTS, is to enable you to easily visualize, manage, and troubleshoot your apps. So for example, if you have a complex app with multiple paths and maybe something is going wrong and somewhere there are slowdowns, one of the features that we have is something called critical path, which when enabled will show you the critical path throughout your DAG, which is when the execution taking the longest time, what is the slowest path in my app. In this case, it's frequently jumping back and forth because the application is fairly well tuned and there aren't any obvious problems, so it's kind of switching from path to path. But in some cases, you may see it persists in one area, and then you will know that, okay, that's maybe the operators that I want to spend time and focus on optimizing them to make them better and faster. So it's just kind of highlighting some of the features that are available. There are many others. For example, you can go to any one of these operators and choose to maybe record a sample of the data that's actually coming across your app. Because that's another valuable way of troubleshooting. If you have some kind of transformation that's happening, and maybe wrong data came in on your Kafka or some other messaging queue, and you're not sure why the numbers aren't matching what you're expecting, you can go and inspect the actual raw data, and you can see it for the various input and output ports. So here we have some number of tuples that have been recorded across multiple ports. And you can see the actual, you can go through it and actually see the raw data. And yeah, so you can filter them, you can select them and kind of inspect what's happening inside your app. All right, so from here, let's talk a little bit about visualizing the apps in real time. So let's go back to the simpler Twitter application, which is again getting tweets in real time, computing the top trending hashtags, and trying to produce those visualizations. So if we go into visualize, I've already created a simple dashboard which will display that, and we're going into it. So here you're seeing that this is live. This is getting the tweets from the Twitter API right now as we speak, and it's showing you top 10 most popular hashtags that are trending on Twitter right now. It's giving you the names of the tags and the counts of how many of each one you're seeing. As you can see, the bars are changing in real time. And this is a really simple example of what a dashboard looks like, and you can obviously change the widgets and resize them, and you can add additional widgets for visualizing this data. For example, if you don't want to see in a bar chart format, you can just add a table, and you can see the same data displayed with tables in real time. I'll talk a little bit about after the visual demo how this data is being queried and how it's actually flowing in. So let's take a look at a slightly more complex example. So let's go back to our Telecom Demo application and take a look at what kind of visualizations are available for it, because here we have a number of operators that are doing all kinds of interesting things, like for example, if you look at the lower path below here, after we're enriching our call data records, we're also tagging them with some geo information, and we're adding some geo visualizations. So that's a different kind of visualization that's available. So if we jump into a dashboard that I've created for Telecom, you can see a number of different widgets available. You have trend indication widgets. You have bullet charts, line charts, pies, and bar charts, and even maps. That, as you can see, they're all changing and updating in real time, depending on what kind of data you're trying to visualize. And here it's specific to telecom operations. So let's say one of these metrics we're trying to visualize is the number of disconnects that are happening for a particular provider. And here I see that it's actually on an uptrend, and disconnects are usually a bad thing. So we can easily go in and change how this widget is working. You can go and change not only can you change the format, because here in the widget it was showing you decimal formatting. So usually this disconnects is a whole number, so we'll just change it to reflect whole numbers. And then you can also say when it's on an uptrend, it should be red, and if it's on a downtrend, maybe it should be blue. So you can easily change all kinds of settings in these widgets, and each one will provide different settings. For example, the CDR, key performance indicators, is a widget which is able to go across historical times. So here you might be able to change range selections. Instead of seeing last 10 events in the 1 minute intervals, you can change to 20 and maybe get a different graph. You can also change the dimensions. You can select certain or remove certain indicators that you don't want to see. And for maps, we also offer a lot of customizations which allow you to even change for example, instead of showing the California and different regions, you can see map of the United States. You can also change a lot of color options for maps and other details. So a lot of visualizations that are available in Data-Torn RTS Console, and it's all being powered directly by Apache Apex applications. It's not connecting to any database to do these visualizations. It's getting these visualizations directly in real time from running operators that are running out there on your Yarn clusters. So let's jump back into the presentation, and I'll give you a little bit of an insight into how, what's happening behind the scenes with these visualizations. So the way we connect to them, as I was mentioning, is by connecting directly through the gateway to the operators. And the way these connections are happening is when the applications are deployed, it's opening a pub sub topics to connect to the gateway through WebSockets. And we typically have a pattern where we will have a query being sent into one operator, and then the results are being sent back from a different operator. And a single widget will connect to one such combination of query and result, and we'll be able to understand what kind of data is available, as well as visualize this data. So what we use for this is what's called App Data Framework. And as I was saying, it's a combination of a data source where your data is being produced and adding a query and result to it. There's a sequence of interactions that happens when these queries are first issued. You first want to know, you'll issue schema queries. You'll subscribe to schema queries and issue a schema query to understand what kind of data is available in your app. It's sent back in JSON format, and it lists, for example, for Twitter, it will list what kind of fields are available, which will be typically hashtags and the counts of the hashtags. And then once you understand, you know which kind of widgets can be used to visualize the data, and then you can say, okay, subscribe to the data query, and just keep returning hashtags as soon as the application produces them. And so it's a connection that's established over WebSocket, and the data just keeps flowing back into the UI, and the UI is able to render and visualize that. So here's a few examples. This is how the schema queries are happening. You connect to the gateway, and then on a WebSocket, and then you issue a request for your data sources, which gives you a list of available data sources. Then you connect through PubSub. You subscribe to a particular topic, and then you issue a query for schema, which just simply asks what kind of fields are available, and then it returns things like, I'll zoom in a little bit, it returns hashtag as a string and count as an integer in the response. And then the next step is you issue a data query. All you do is you say, okay, yeah, I like those fields, so give me hashtags and counts. And then the next set of data that starts coming back as it's available in the system looks like this. It's just a JSON array of objects which have counts and hashtags inside them. And that's what drives the visualizations that are available. So in pure Apache Apex, the easiest way to enable visualizations is to add them through autometrics. All you do is you add an annotation for autometric on top of the variables that are declared inside your operators. So here we have a line receiver operator, which extends a base operator from Apache Apex, and you just add the annotation in yellow, which specifies that this will be an autometric. And as soon as you have done that, the metrics for that particular operator will be available. And of course, so these are for basic metrics, maybe equivalent to counters in Hadoop. But for more advanced use cases, we support other types of, we support snapshot schema for sending data equivalent to what we saw in the Twitter example. We have hashtags and counts, just give you the last frame that is available in time. And then we have a more complex schema that we support, which we call dimension schema, which can basically give you a series snapshots over time, and you can request either last 10 units or last 20, or you can go back in historical time, however long the state is available inside the operator. And that's up to you to determine how long you want to keep that. And finally, these visualizations and dashboards that I showed you, they can all be easily exported and saved. Each dashboard is basically a JSON file that can be easily packaged later inside your own Apache Apex applications. And then when it's been packaged in the way that's outlined here, you can then later import it, and it'll be available and ready for you. You don't have to reconstruct the dashboard again. So with that, I'll conclude, and I will open to any questions that you guys may have. Yes?
Have you ever compared with environmatics plus Grafana with your Apex for the data visualization, especially for the dashboard?
Yes. So the question is, have we looked at using Grafana for visualizing data from Apex? Yeah, we actually have looked at it. Grafana, in fact, there's a concurrent talk about Apache Apex that's going on in a different room, where one of the PMC members from Apex is in fact demonstrating how Grafana can be connected directly to Apache Apex and using Grafana's visualization tools. So there's multiple ways of doing it. You can either connect it directly, kind of like so here we're shortcutting a lot of steps. We're just directly giving you the data, sending it to the UI immediately, with the setup that you can find in the other talk. There's a few extra hops that are happening, but basically they created a plugin to Grafana, which is able to talk to the operators in real time and visualize the data that way. And of course, you can also store the data to some kind of data store like Graphite or some other variant and visualize data that way. So yeah, those are all options available to you.
How about the security, like for the Apex?
The security?
Yeah. It's like the cover.
Oh yes. So Apex. So we support different security settings. With Apex natively supports all the security that Hadoop supports. You have support for Kerberos, and those we're looking at integrating with. We've already integrated with a number of other Apache projects, and yeah, we have some of those in our roadmap. Yep. Mm-hmm. Sure. Go ahead.
Who keeps track of the historical data for the metrics? Is it kept by the operator or by the front end?
Right. For historical data, so what I was showing you there, for example, with this line chart, when I was showing you the historical data here, it's actually all being queried from the operator's state initially, but some of our operators, we have written, there are different mechanisms you can use. One of the ones we have written, it actually has spillable data structure, which can spool additional state that you cannot keep in memory onto HDFS, and you can go back and query it on HDFS as well. And if the data that you're querying for is not available in memory, it'll reach out and get it from HDFS. So that's one way to go. But if you're looking for doing, so this is just to get you past like memory barrier, but it's not necessarily something that I would recommend to use for queries that go back 1 year, let's say. If you go that far back, I probably would recommend you using some other data store that you typically be writing. You don't want to lose your data. You want to get actions and insights on your data as quickly as possible, and then you want to probably also preserve it on HDFS or some other storage of your choice, and then you can do historical queries on it separately later.
For the query result, is it like only the delta, the new value gets passed back, or all the values?
Yeah, so right now it's implemented in a really simple way. It's stateless. So we're not sending you deltas, we're sending you all the data that's currently available. But it makes it easy because you don't have to wait when you open visualizations. You don't have to wait for more changes to come in to give you full display. Yeah, go ahead. Yeah, good question. So which framework is being used to display the widgets? So right now you're looking at the DataTorrent RTS Console, which is built on top of another library which we've open sourced, which is called Mulhar Angular Dashboard. It's a library that basically allows you to have all kinds of things like this, like where you can move the dashboards around, resize things, and operate with it. It's all built in Angular and JavaScript, and the visualizations themselves, a lot of them are built with, underneath they use some elements of D3, so that's kind of some of the building blocks for this. Okay, any other questions? No? Yeah, go ahead.
Now there's this thing called application timeline service.
Okay.
That keep track of some of the application level metrics. Have you looked into any overlap between this work and that?
So in Yarn, there's an application timeline service?
Yeah, that keep track of the application level metrics such as.
Yes, correct. So we're actually, so for the metrics, so these are the raw data visualizations that we were just looking at that are very specific to the app that you're creating, like Twitter top 10 hashtags. But all the metrics that you're seeing here for the whole cluster and for each individual application, when I jump into the monitoring tab for a particular app, all these states are actually streaming directly from Yarn. So we're constantly connecting to Yarn, and we're getting all the data back from Yarn all the time. So yeah, all the things that we don't need to do, we don't do. Yeah. Okay. Any other questions? Okay. Thanks, everybody. Thank you.